In this module, you will learn about the addition and subtraction operations performed on matrices. Arithmetic operations, such as addition and subtraction, are possible on matrices of the same order. However, the arithmetic operations are done on the elements of the matrices. Let's start by exploring the addition operation on two matrices. We have two matrices, X and Y, of the same order. If we are performing the addition operation on X and Y, it means that we are adding the elements of X to the corresponding elements of Y. Let's see how it's done. The element in the first row and the first column of matrix X is added to the element in the first row and the first column of matrix Y. Similarly, the other corresponding elements are added as shown. It has to be noted that matrix addition can be performed over matrices having the same order. If X and Y are two matrices of the same order, say M by N, then the sum X plus Y is defined as a matrix Z of the same order, where Zij is equal to Xij plus Yij for all values of I and j. An example of the addition operation over two matrices A and B is shown here. The sum operation is shown here. Every element of A is added to the corresponding element of B. The sum of the matrices A and B is as shown. The addition operation over matrices satisfies the commutative law and the associative law. First, we will look at the commutative law. If the matrices X and Y are of the same order, M by N, then X plus Y is equal to Y plus X. When we add the matrices X and Y, we actually add the corresponding elements of the two matrices. We know that the addition of numbers satisfy the commutative property. Therefore, the sum of the elements can be written as shown, which in turn is equivalent to Y plus X. Now, let's look at the associative law. If the matrices X, Y, and Z are of the same order, M by N, then X plus Y plus Z is equal to X plus Y plus Z. Let's verify the associative law over matrix addition. This proves that the addition operation over matrices satisfies the associative law. An additive identity exists for a given matrix. Let X be an M by N matrix and let O be an M by N zero matrix. Then X plus O is equal to O plus X, which is equal to X. In other words, O is the additive identity for matrix addition. Let's verify the additive identity. Similarly, the additive inverse of a matrix can be defined. Let X be any matrix. Then we have another matrix as minus X such that X plus minus X is equal to minus X plus X, which is equal to O. So, minus x is the additive inverse of x or the negative of x. Here, O is a zero matrix. A matrix can be multiplied by a scalar. Here, a scalar is any real number. The idea behind scalar multiplication is similar to the multiplication operation over two numbers. For example, if we multiply two numbers, a and b, we are adding a, b number of times. Similarly, when we multiply a matrix X with a scalar a, we are adding matrix X with itself a times. If A is a matrix of the order m by n and K is a scalar, then Ka is another matrix of the same order, which is obtained by multiplying every element of A by the scalar K. Let's see an example. X is a matrix. We will multiply the matrix with the scalar 4. The resulting matrix is 4x as shown. Based on the multiplication of a matrix by a scalar, we can define the negative of a matrix. The negative of a matrix X is defined as minus x. The negative of a matrix X is obtained by multiplying it with the scalar minus 1. We will now see some properties of scalar multiplication. If A and B are two matrices of the order m by n, and K and L are two scalars, then their multiplication will have certain properties. Let's look at the first one. K multiplied by A plus B is equal to Ka plus Kb. This can be proved as shown. Now, let's look at the second property. K plus L multiplied by A is equal to Ka plus La. This can be proved as shown. Similar to the addition operation, the subtraction operation can be performed over two matrices. Shown here are two matrices X and Y, which we used earlier. The subtraction of matrix Y from matrix X is denoted as shown. The resulting matrix is Z. The subtraction operation over matrices X and Y is shown here. The resultant matrix Z is of the form shown here. We will see an example of subtraction using matrices A and B that we saw before. The subtraction operation is shown here. Every element of B is subtracted from the corresponding element of A. The difference of the matrices A and B is as shown. If A and B are two matrices of the same order, say m by n, then the difference A minus B is defined as a matrix D. In other words, D is equal to A minus B, which in turn is equal to A plus minus 1 multiplied by B. That is, the sum of matrix A and the matrix minus B. It has to be noted that the subtraction operation is not commutative.